So we got this situation. Let m be the smallest positive integer such that the coefficient of x square in the expansion of this ugly thing is this. Okay, so they have already given you the coefficient as well. Okay, for some positive integer n. Okay, then the value of n is, now look at this, they have introduced two variable m and n, and they have given you only one equation, so you know that you have to apply hit and trial method, correct? So look at this, how we will approach this question. So we have 1 plus x power 2 plus 1 plus x power 3. This thing will keep on going till 1 plus x power 49, and then we have 1 plus mx power 50, correct? Now if you will observe till this part, this is following some different trend. Okay, suddenly it has something different in it, means the coefficient of x is different. Okay, so just observe your first entity. So if you'll observe your first entity, you will find out these guys are in GP. Okay, so we can apply sum of n terms of GP. So Sn is what? A r power n minus 1 by r minus 1, correct? Now look at this part. So we have how many terms? You know that it starts from 2 and ends at 49. So if it will start with 1 and with 49, you will have 49 terms, but it starts with 2. So you have only 48 terms. Okay, so let's do the sum of first part. So we will have a r power n. What is the common ratio? You have 1 plus x, next term divided by first term. So r power n 48 minus 1 by r minus 1. So 1 plus x minus 1. Okay, so we got this as our first element. Now plus 1 plus mx power 50. We cannot handle this part. Now this thing gone. Okay, now let's do the multiplication. We got base same power add. So can we write 1 plus x power 50 minus 1 plus x power 2 divided by x plus 1 plus mx power 50. Okay, now look at this. Suppose that we want to find x power 2, coefficient of x power 2. So look at your first observations, first part. So if you'll observe, on denominator x is waiting, okay, to neutralize your entity which will come outside, correct? But at the end you wish to have x power 2. So what we will do? We will make sure that outside bracket x power 3 will come, then only after neutralization you will have x power 2. So we want x power 3 to come outside. And when we will have x power 3? If we will be using 50c3. Okay, and also you know that this 1 and this x will not contribute in coefficient. Okay, they don't have any different number na, so they won't contribute. If you'll observe this thing, you know that x is waiting outside, so you want x power 3 to come outside. But if you'll observe this, you have power 2, so max to max x will take power 2, not 3. So from this part you won't have anything. Now look at this, from this part you want to have x power 2. So yes, it is possible. When we will have this thing possible? When we can use 50c2, and here this entity will contribute in x power 2. So it will have m power 2, correct? So according to us, the coefficient of x power 2 is this, but according to them, x power 2 is this. So let's equate. So 3c1 plus 1 and then 51c3. Okay, now let's do the little bit of simplification. So we have 50 factorial, 3 factorial, 47 factorial plus 50 factorial, 2 factorial, 48 factorial, m square equals 3n plus 1, 51 factorial upon 3 factorial, and we have 48 factorial. Okay, now be little bit slow and observe. So if you'll observe the numerator, you have 50 factorial, 50 factorial and 51 factorial. So you know that the least one is 50. So 50 will get neutralized. So this thing gone, and we are left with 51. Okay, now so from first part you have 1 in the numerator, plus from second part you have 1 in the numerator. Now observe the denominator. You have 3 factorial, you have 2 factorial, you have 3 factorial. So who is the least one? So least one is the 2. So 2 will get neutralized. So 2 factorial gone, 2 factorial gone, 2 factorial gone. So we will be left with 3, 3. Okay. Now observe 47 factorial. So we have 47 factorial, 48 factorial, 48 factorial. So you know that the least one is 47, 47 factorial. So 47 factorial will be neutralized, and we will be left with this side 1, this side 48, and that side 48. Okay. Now here in first element we don't have anything in the numerator, but in second element you have m square, and in third element you have 3n plus 1. Okay, now can I multiply both side by 3 so that this person will be neutralized? Okay, 16, 3 will be neutralized. Okay, and also you can neutralize this 51. So it is 17, it is 16. Okay, so can I multiply both side by 16? So we will have this thing as 16 plus m square equals to 51n plus 17. Okay, means I have multiplied both side by 16. Okay, so we have m square is equal to 51n and plus of 1. Okay, so we got this equation. Now we have to apply hit and trial method. Now you know that m is a smallest positive integer. So m should be smallest positive integer. Now look at this. So if m is smallest positive integer, so m square will be smallest perfect square number. Correct or wrong? So it will be smallest perfect square number. So try to find out smallest perfect square number. So we will apply hit and trial method. So I'll go with n. Okay, and at that time I will try to find out m. M should be positive, and who is the n? N is also positive. Okay, now be super slow. So just tell me, can I take n as 1? Yes, you can take, but if you will apply, you will have 52. 52 is not a perfect square number, so reject 1. Now can we take n as 2. So if we will take n as 2, it will become 102 and then plus 103. You know that it is not forming a perfect square number. So reject 2. Now take n as 3. So if we will take n as 3, so it will become 153. So it is 154. 154 is not a perfect square number. So it is wrong. Now let's check 4, n to be 4. So it is 204 plus 1, 205. 205 is not a perfect square number, so reject this 4. Okay. Now I wish to take n as 5. So if you will take 5, it is 225. 225 plus 1, 226, 9, 5, 256. Okay, so it is 256, and yes, 256 is a square of 16. Okay, 256 is a perfect square. So we got combination of n and m, both are positive, that's why we have taken positive m. Now what was the required thing? We have to find out the value of n. So the required value of n is 5, and if you want to go with the ordered pair, so it is 16 comma 5. I hope you got the approach and you can handle similar situations. Okay.